everyone. Welcome to Critically Thinking with Group 1. Today, I will be discussing Polya's problem-solving principles and the standards for mathematical practice of the Common Core. First of all, I would like to start off by doing something light like telling a joke. And this little riddle goes, why did the girl wear glasses during math class? Because it improves division. I know it's kind of cheesy, but I hope this kind of makes you a little bit less skeptical about learning math. First of all, I will be talking about Polya's problem-solving principles. And I will show you right now. So, I will be talking about Polya's problem-solving principles for the mathematical practice of the Common Core. Polya, this is George Polya. He is the creator of Polya's problem-solving principles, which is kind of awesome because he's the one that came up with all the devising the plans. They were created by him. He was a Hungarian mathematician as a way to teach students problem-solving skills. He recognized that not everyone was naturally good at solving problems, but everyone could be taught the skill. Polya's method consisted of 4 principles, which you can, if you can see right here, is understanding the problem, devising a plan, and carrying out the plan. Looking back is number 4. Sorry. Now that you've know a little bit more about Polya's problem-solving strategies and the Common Core standards, I hope you can use it in your math everyday working problems. Next up is Crystal Lambert with Guess and Check.
Guess and check. Is guess and check a legitimate method for solving a problem? Yes! Scientists use experiments. We're going to use guess and check. We're going to make educated guesses to solve our problem, right? Okay. So here we go. We're going to work through a problem. Ben knows 100 baseball players by name. 10 are Red Sox, the rest are Blue Jays and Diamondbacks. He knows the names of twice as many Diamondbacks as Blue Jays. How many Blue Jays does he know by name? We can work on past this. Okay, so first is we're going to understand our problem. There are twice as many Diamondbacks as Blue Jays. There are 10 Red Sox, and the number of Blue Jays and Diamondbacks should equal 90. Then we have to devise a plan. Is there an obvious strategy? If there's not, we have to make educated guesses. We're going to guess. So first we know that there are 10 Red Sox, no matter what. Then we're going to go ahead and use 10 for the Blue Jays, and we know to double that for 20 for the Diamondbacks. That gives us a total of 40. Well, when we analyze that, then we know now we need to guess a number greater than 10. So there's automatically 10 Red Sox. And then we're going to use 40 for the Blue Jays, double that to get 80 for the Diamondbacks. And that gives us a total of 130. And that is way too big. We're looking for 100. So let's guess a number smaller than 40 and greater than 10. Well, let's try 30 this time. So we're going to put 10 under the Red Sox, 30 with the Blue Jays. That makes us have 60 Diamondback names, and that gives us our total of 100. So when we look back, sometimes what we need to do is analyze our problem and say, is there anything we could have done that would have to use another strategy to make this work better? I'm not seeing that, and this works. We looked through, we guessed the first time, and then we looked at our total and we analyzed it, and we realized, okay, we need a bigger number. And each step, you are constantly readjusting and making an educated guess at what we need to use for our next problem. So guess and check works with works really well with a little bit of information, but sometimes we are given so much information in our word problem that we have no clue or any idea of where to even begin. So Miss Wynn's gonna let us know how we solve those problems. Did I unshare?
No. Thank you, Miss Lambert. Have you guys ever looked at a problem that had so many possibilities and you had no idea what to do with it? Well, I'm going to tell you about making an orderly list. So we're going to make an orderly list. The reason you make an orderly list is to help solve a word problem that has several possibilities. The list will be a table of all the information that you were. Here's my example of it. So Emma has 5 bills in her bank. There's no bill greater than $5. How much money could possibly be in Emma's bank? So I've made a table. You want to start with the least amount and work your way down so it's an orderly list and you don't miss one possibility. So if there's 0 5s, she'll have 5 1s for the total amount of $5. 1 5 and 4 1s will be $9. And you'll go down the list working it just like that. Does anybody see a pattern for the total of amount of how much money it's going up each time?
It goes up by 4.
Very good. So Emma could have a possibility of $5, $9, $13, $17, $21, or $25 in her bank using an orderly list or a table to show your information. Now, when you look at a word problem that has endless possibilities, you shouldn't be so scared to work it. It's very simple when you break it down and you write down your information in an orderly fashion. So now to Miss Cat Knight for drawing the diagram.
Thanks, Laura. Okay, so to conclude, I am going to discuss drawing a diagram. And drawing a diagram just really visually appeals to people who may not love word problems. For me, I know I don't love word problems, and there have been times when you're scrolling through your math book and then all of a sudden you get slammed with a word problem that looks something like this, and you think it's the end of the world, and the only thing you can possibly do is, well, that. So how do we break this down? How do we fix this word problem that seems endless? It seems like there's nothing that we could possibly do about it. Well, we can make it look very visually appealing to us, and we can, get the information by simply glancing at something instead of reading over the paragraph again and again. And there are many, many ways to do this. And of course, one way is not better than the other, but it really does depend on the problem, and there are even multiple diagrams you can draw per problem. It really depends on the person who's doing it and whatever helps you. So a few very common diagrams are graphs, and we've got a bar graph, a line plot, and a pictograph. And as you can see, you can just very simply glance at this to get the data that you might have got from reading through that long paragraph. And here you can just easily see there are 8 dogs, or 8 students have dogs, instead of reading through a list to find that 8 students have dogs, as many have cats, as many have fish, and so on and so forth. Same goes with line plot. It's the exact same concept in a pictograph. Again, same concept, just a little, looks a little different. So we're going to put this into play a little bit. I am going to show you a problem, and I'm going to work through it by drawing a diagram. It is very simple, and it makes the problem seem like it's no big deal. So our problem is Masumi has 3 different colored tops, red, green, and white. She has 2 different colored skirts, yellow and pink. How many combinations of shirts and skirts can Masumi wear? So to work through this, we are just going to simply draw a quick little diagram. So for shirts, we've got red, green, and white. And then for skirt, we've got pink and yellow, pink and yellow, pink and yellow. So now we can create our different combinations. So now we've got red and pink and red and yellow. Got green and pink, green and yellow. We've got white and pink and white and yellow. And then we can just simply count these, and we've got 1, 2, 3, 4, 5, 6. And that is the answer to the problem. There are 6 possibilities that she can have. It is that simple, and it just simply creates a way to it just simply creates a way to visually see a problem that is in front of you instead of getting overwhelmed by the amount of words that are in front of you. This concludes Group 1's presentation on critically thinking. So thanks, ladies, and thanks, everybody, for joining Group 1.
Bye.
See y'all.